Okay, so let us quickly recall what we did in last lecture. So we took a problem where the two masses were connected by this massless rod with length L, and their external force was applied on mass M2. So we solved this constraint problem uh, using various methods, and finally we got this expression equal to F divided by M plus M. So we can use this to simulate this system. Okay, so then what we did was something which we call as a DAE method. So in this we draw the free body diagram for first mass and free body diagram for the second mass, and we wrote the constant equation in terms of acceleration. Okay, so and then we rewrite this equation in matrix form, and this was what we got at the end. A zeta double dot equal to B. So here zeta double dot is nothing but acceleration of first mass, acceleration of second mass, and the tension in the rod. So we can solve for this vector by zeta dot equal to A modulo B. Okay, and then we took another problem, that is hanging simple pendulum, that is a mass M hangs about this point, and this was XY axis. So we wrote the equations of motion using DAE method, where we took F total on this mass and equate with the linear rate of change of linear momentum, which is mass times acceleration, and then this F total was nothing but tension and the gravitational force, and finally we wrote the constant equation, which was this. We find its derivative to write the constant equation in terms of velocity, and then we again differentiate it to get the constant equation in the form of acceleration. So these three equations we got. So basically we got two equations. One is this and another is this, but this is a vector equation. So we took the dot product of this equation with I and with j. We got two scalar equations, which are these two, 1 and 2, and we had this constant equation. So we got three equations. We put those three equations in matrices form, and we got this matrix. So now until this we did. So now let us try to simulate this problem, that is a pendulum problem. So basically we are in search of this vector x double dot y double dot. If we somehow get this thing, we will integrate this to get the velocity and integrate the velocity to get the position at each instant of time. So this is A and this is Z double dot vector and this is B vector. So in MATLAB, what we will do, we will define Z as X, Y, that is X position of mass, Y position of mass, and X component of velocity and V component of velocity. So X and Y, if we write this as 1, we can write it as R. And Vx, Vy as velocity, that is V. So Z is also equal to R and V, where R has two components, X and Y, V has two components, Vx and Vy. Now, in MATLAB, what we will do, we will calculate the Z double dot. This is Z double dot, not Z dot, as you mentioned in previous class. So this is Z double dot, it is equal to my RHS. T, Z, and P, and we will see how we will go through this. But let's assume that we know this Z. By this, I mean that we know at any instant of time, we know X, Y, Vx, and Vy. So first, what we will do, we will unpack this Z vector. We will unpack it in terms of R and in terms of V. So what is R? R is nothing but first two, X and Y. That is first two components of Z. That is Z of 1, 2, 1 to 2. Z of 1 and the second will be Z of 2. What is V? V is nothing but 3 and fourth element of Z. That is Z 3 to 4. And then we will define the constraint as L equal to norm R, which is nothing but the distance of mass from the origin. And X we can write as R of 1. We have already got the Z. We can write X as R of 1 and Y as R of 2. We could also write this X equal to Z of 1, because Z of 1 is similar to R of 1. And Y equal to R of 2 is similar to Y equal to Z of 2. But X dot equal to V of 1, that is first component of the velocity, and Y dot is nothing but second component of velocity. We can also write it as Z of 3, and we can write this as Z of 4. That is from here. Okay, when we get this, then we define our A matrix as M0 X by L and this. So see, we know X at this instant of time, we know M, we know Y from here. Similarly, then we define this B as 0 mg x dot square plus y dot square. So we have x dot square, we have y dot square, because I am assuming that we know Z. So we know Z, we know this thing, we know this, we know this. So we can calculate this matrix, we can calculate this matrix. So when we get these two matrices, then Z double dot, again I am emphasizing this is not Z dot, this is Z double dot, which is nothing but this vector is nothing but A modulo B. A modulo B. So basically, this is how MATLAB solves this linear set of equations. If you give so these are actually three um, linear equations in three variables. So we have to simultaneously solve these equations. So MATLAB does this for us, and how it do it like this. Okay, so now let us shift it.
Sir, can you scroll up, up, up? Sir,
Yeah.
repeat this. Down, down, down. Just yes, down. Little bit. Yes, sir. R is equal to Z and X is equal to R. Repeat this, sir. This 1, 2, 3, 3 liners.
Okay, see, what is Z? This is nothing but X, Y, Vx, and Vy. Okay, this is a vector. This is a vector which contains four things. Its first component is X, its second component is Y, its third component is Vx, its fourth component is Vy. Okay, is it
Okay, sir.
clear?
Okay.
Then I define this. What is X and Y? If I write X and Y as one entity, it is nothing but R vector, position vector. Yeah.
Yes, sir. Yes, sir. Position vector in terms of X and Y.
Similarly, I can define Vx and Vy as single
Velocity.
vector, that is velocity. What is R? R was first and second component of Z.
Yes, sir.
That is how I extract it.
That
Z of 1 and 2. When
1 and
I
2. Okay.
write this command, it will pull out these X and Y
X and
from this
Y.
text. Yeah.
Yeah.
Similarly, V is nothing but 3 to
3
4.
to
That is
3 to
third component and fourth component. This is Z.
yes, sir.
Okay.
3 root. Okay. Okay.
Then I was saying that X is R of 1. See, X is nothing but first component of R.
Yes,
And
yes, sir.
y is nothing, second component of, or
Yes.
equivalently I can tell that x is first component of z and second component of z.
Of Y.
See,
Yes, sir.
vx is first component of v and vy is second component of v. Equivalently I can say vx is third component of z or
G
third
and
component.
Y. Yes,
Yeah.
sir.
So this is how I extract x, y, x dot, y dot. Because why I am extracting these things, because to get the value of a and b we need these things. See, in x we have x and y, sorry, in a we have x and y, in b we have x dot, y dot, so I need these things. That is why I am predefining these things, and then I can calculate a and b at this instant of time. Okay, these are at a particular instant of time. So I am solving this, I am solving this. So when I solve this, then I have A and I have B. I need to get this Z dot double dot. This is nothing but Z double dot. Uh, um, if I take A inverse on both sides, we can get A inverse. Similarly, I can get here A inverse
Into B.
B. But
Yes.
that is something which is inbuilt in the MATLAB. So we just write A modulo B. It will directly give you the
Z
value
dot.
of these. Okay, Z double dot. Okay, so you have Z double dot. Now you have Z double dot. Now that is, you have acceleration. Okay, so when you have acceleration, you will integrate it, you will feed it to OD will integrate it to get the velocity, again integrate it to get the uh,
Position.
um, okay. Okay, now let us go to MATLAB and see how it works. So uh, close all, close C. Oh, first, you should write, whenever you write some code, write your name, write what you are trying, what problem you are simulating, and what is the method. So we will be solving this using DAE method, and also don't forget to write the date. Uh, okay, so close all will close everything, that is every figure it will close. If there is any window showing figure, it will close it. And CLC will do, it will clear your command window which is here. If there is anything which is here, it will clear it. And then clear all will remove any variable which is there in workspace. This is a very good practice to write this in the front, because what happens sometimes is you debug your code, you try to find out error, and but when you run the code, you will not get the right answer. The thing is that there are already preoccupied values for the variables. That is why we use these things. Okay, now T end is the simulation time for which you want to simulate your simulation. Speed, you know, it is animation speed. And t-span is nothing. So see, I am writing t-span is equal to 0 t end. So this is nothing but it will give us 0 and 5. So it means that we have to integrate. I will feed this to ODE. So ODE will understand that they need to integrate the solution from 0 to 5. Okay, so this is now parameters. So what parameters do we have? So see from here. So we have mass, we have length. These are our parameters, isn't it? So I am defining this parameter p dot m1 equal to 0.5 kg, p dot l equal to 1, that is length is equal to 1, p dot g, that is gravitational constant, is 10 meter per second square. Okay. So why I am writing p dot m? Because I am defining these parameters as a single entity, that is p. Every parameter is called in this p parameter, p entity, and we call this as structure. So you can see here in workspace, there is a particular symbol for this structure when you define
Yes, sir.
structure.
Class. Correct.
Okay.
Yes.
So basically there is a tree. So if I write it here, so basically what I am doing, I am defining. Okay, so I am, if this is P, so then out of this P, three things come out. One is P dot, sorry,
M period
first is
M1
M1, L,
L G.
and G. Okay, but how we can define this structure? So in MATLAB, how we define this structure is like this: P dot M1, P dot L, P dot G. So when you write this, automatically a structure is created like this. Okay, so when you have written P dot M1 equal to 0.5, so basically a structure has already been defined with M1 equal to 0.5. Similarly, L equal to 1 and G equal to 10. But to use these M1, L, and G in this code, in this main file, you have to define, you have to write this, write these things like this: M1 equal to P dot M1. Otherwise, if you want your value M1, you have to write P dot M1. You cannot write M1 because MATLAB doesn't know what M1 is. Okay, so you have to write it as M1 equal to P dot M1. Now this main code will understand, okay, this M1 is P dot M1. Okay, and what is that equal to? That is equal to 0.5. Similarly, L
0.5.
is nothing but P dot L. Okay, so these are the parameters. Okay,
Sir, what
this
is this theta
okay,
35?
okay. Let us remove this. Go to this. Okay, so what is this theta zero? It is actually I am trying to write the angle in terms of radians. So I am taking
Oh yes, sir.
30 degree and I am writing it in
Yes,
terms
sir.
of radian. See, I could have directly
One-
taken the value in terms of radians, but in radians we don't have intuition. For example, if I am taking the 30 value, you will know, okay, so the pendulum is here. But if I take something 30 in radians, you don't know where it is. That is why I am using 30 so that you know where the pendulum is. But see, but in equations you can't use these things because sometimes what happens, there's this radian is compatible with our equations, but degrees are not.
It is not.
So I changed it to the radians. Okay.
Okay.
Okay. So then I write this x10 as L cos of theta and x20 as L. Okay, now let us go to whiteboard and see what we can write. So if this is, if this was our y-axis and this was our x-axis and this was our pendulum, and let's assume this is theta, then we can call, if for example initially we have some angle theta naught, okay, then this distance will be called as x naught, that is initial distance, and this will be called as y naught. So what is x naught? It is nothing but L cos of theta naught, and y naught is nothing but L sine of theta naught. So these are initial conditions. Okay.
Okay, sir.
So, okay, so we have x1. So I am not calling y and x. I am just calling x1 as x and x2 as y. Why? Because when you have large number of, for example, variables, you have x, y, z. And then, for example, we have 10. What will you use? X, Y, and Z. Then what? Then nothing. So I am trying to use X1, X2, X3, X4, X5, X10. That is why I am using for X, I am using X1, and for Y, I am using X2. Is it clear?
Yes, sir. Yes, sir. Clear.
Okay. So we have got the initial position, and similarly, initial velocity. Initial velocity is x1 dot 0. X1 dot is velocity in x direction, and 0 I am writing because initially this is the value at
Initial,
t equal to
initial
0,
velocity.
and
Yes,
similarly
is equal to
this
0.
is also 0. So I am starting with 0 velocity. No velocity is
Velocity.
given to the pendulum or to the mass. And now this is z naught. So our vector, how many component did do it have? 4.
4.
See,
4.
4 x, y, vx, and vz.
Yes.
So go back to this. That is why this is x1, that is x, x2, that is y, and vx, that is x1 dot, and vy, that's okay. So these are the initial. Why I'm taking initial value? Go back to this. I was assuming that I know this. Okay, I assumed that I know this.
T
That
is
is
at
why
T.
I know this Z. I assume that I
Yes.
know this Z. And obviously
Initial value
T
of Z.
will be something, so I know T. P is
Yes.
parameter and I know parameter. So everything here I know.
Okay.
But focus on this Z. So I was assuming that I know this Z. So that is why I took some known values of Z. This is known as initialization. That is, initially we put some values to Z which we know. Okay. So initially we know this Z, isn't it? So we can calculate all those things initially. So we can calculate A at time equal to 0, B at time equal to 0, and Z double dot at time equal to 0. Okay. Now
Yes,
this
sir.
will be feed to the ODE, and ODE will integrate it and will give us the estimate for next time step. Okay.
Yes,
So
yes.
we will
Parking time
get
T.
the,
Yes.
yeah, we will get the values for Z in the next time step. And then we
Yes.
know, again we know Z, we calculate A and B for next time step, again feed it to the, so it will keep on running. But the crucial step is that at initial time you have to feed it this Z vector.
Initialize this.
Yeah, that is why I initialize it. Okay. Now, um, okay, let us jump to, so what is this? What is this function and what is this? And let us go to the function itself. So see,
Sir, somebody wants to join your class.
oh, I didn't notice. Is it who wants to join? I am not getting.
Guests are waiting to join. View lobby.
Why I'm not getting?
Leave, leave. It disappear, sir.
Oh, just wait a minute. If someone, I will put a message. If someone is trying to join, try again, and then we can continue. Let me know if someone tries to join. Okay.
Okay, sir.
Okay. Let's continue. So I was saying that function, this thing, how we will write this. Yeah. So see. in MATLAB. First, we will calculate this z dot. How actually this is z double dot, not z dot. I don't know why I'm writing it. Okay, let me correct it here. Otherwise, I will never correct. So z double dot is equal to my RHS. This is name for the function. You can name anything you want. This is the name. My RHS is something you name. This is how you define the function. Okay. For example, you have some function, and what is the name of the function? My RHS is the name of function. What are the inputs to the function? That is what should we give to the function in order to calculate something? T, Z, and P. So we have to give input to this function T, Z, and P. Once we give these input to this my RHS, it will calculate something and will return you that thing. What is that something? Z double dot. So give this function these three things, it will return you Z double dot. How it will do this? That is something which we are writing here. So again, see, P we defined here. P has been defined here as a structure. Okay. And we also define this M1, M1, L and G. We are defining this M, L and G. But those will not be available to this function. If you don't define these things again here within the function, those will not be available to this function. This is how MATLAB works. I don't know why they have put these things as such, but this is what is there, that you have to again unpack this P as M1 equal to P dot M1, G equal to P dot G, and if you need anything else, you have to define those things also here. Okay, is it clear?
Yes, sir. Yes, sir. It is clear.
Okay, now we know this z, isn't it? That is what we are saying, that to this function we know this z. We are feeding some z value. That is, in z we have these four values: x, y, x dot, v dot. So we will unpack position from this z. What is x1? That is z of, that is first component of z. What is x2? Second component of z. What is x1 dot? That is third component of z. What is x2 dot? That is fourth component of z. And we can write this position vector r as nothing but x1 and x2 as a column vector. Is it okay? X and y.
Okay, sir. Yeah,
And
yes.
similarly, we can write this as this velocity vector as x1 dot and x2 dot. That is x component and y component of the vector. Now r dot, that is velocity. R dot is equal to this v. I have written this r dot as v. This is same as velocity. These two steps are not needed, r and v, but it is okay. I have defined these like. Otherwise, these are not necessary. Okay. Now x by L. If you remember, here we have this x divided by L. So I have defined this variable like this, x by L. So what was this x by L? This is x1, which is this x component, upon L is nothing but square
Root
root
of
of
x
x square plus x2 square. We could have also unpacked L here. That is L, capital L equal to P dot L, because in this P we have L. But it is okay. I have written it like this. This is also fine. Similarly, y by L is equal to x2 upon this. Okay. So now after this, I define this A matrices, which was here. We have A matrices. So I define it M1 0 x by L 0 M1 y by L. Similarly, I define this B as 0 minus M1G. This is the column vector, and this x1 dot square plus y1. Okay, these two vectors I am defining. Is it okay?
Yes, sir. Yes, sir. It is okay.
Okay, so after this, uh, now we can write this R double dot. What was R double dot? See. Okay, okay. First, let's this W I will rewrite as what should I write? Let me call it as Z
Z double
double
dot.
dot. Okay, so Z double dot was this, isn't it? I have solved this. So I
Yes, sir.
within this Z double dot, how many elements I will get? Three elements. First
Three
will be X
elements.
double dot, second will be Y double dot, and third will be T. Is it? But
Yes, sir. T.
I need only X double dot and Y double dot. So I will pull out first two. Okay, that is why I am writing Z double dot 1 to 2. So I will, this will return me X double dot and Y double dot, and I will store that in R double dot. Okay. Okay. So, and then Z double dot is nothing, which is this. See, this function will return me Z double dot. And what is Z double dot? That is this R dot. Okay. That is this. Uh, oh, now I got why I was. Okay, but so I
This
will
is sir.
get R double. Yeah, yeah, yeah.
Z double dot is equal to R double dot comma Z double dot.
I
It will
will
be true.
not write this as Z double dot. There is a reason. I will tell you. Just a minute. I was thinking why I was writing Z dot. This is just Z dot. Okay. This is not Z double dot. This is just Z dot because in Z dot this is nothing. This is R dot, and this is nothing. This is V dot. Okay.
Yeah. Okay. Yes. Yes, sir. Yes, sir.
This is V dot. Uh, that is why we call this as Z dot.
Z dot. Yes.
Okay. I think we should. Okay, but this is fine.
So
If
it's
you are comfortable with, then it is fine. Otherwise, we can change the notations.
no, it is fine, sir.
Okay. So we got our velocity and we got our acceleration. Okay. Now we will feed these two, and these two will be stored in what? In this Z dot. So this basically Z dot has how many components? Two velocity components and two acceleration components. So basically it has four components. So we will integrate this Z dot to get Z, to get this Z. So how we will do this? Now going back, remember this, my RHS gives you Z dot.
Z and
Come back, see, I am defining another function, my RHS. Let me call this not as my RHS, I will call it as RHS uh, just RHS. My RHS. Okay, so I am defining another function RHS. This RHS is nothing but the function I have to feed to this ODE. Okay, I have to feed this RHS to ODE. What this RHS is, it is nothing but it is my RHS itself. But only thing is that in my RHS, it was function of T, Z, and parameters. But I have already told you that MATLAB ODE takes only the functions as function of T and Z. So I have to first make this my RHS as function of T and Z only. Okay, is it clear?
yes, sir. Yes, sir.
So how I define new function? That new function is nothing but RHS. And this new function is function
Depend on
of
Z.
T and Z only. T and Z only.
Yes.
Okay.
On
Okay. So this is basically, it will return the same Z dot, but uh, this will now be function of Z, T and Z.
T
Now I am
Z.
feeding this R and RHS to my ODE. Okay. So ODE, first we feed it this function, and then T span, which we are defined here, for how much time you, for how long time you want to integrate this, and then we feed initial condition to this integrator, that is ODE 45. We initiate from here, and then there is this options. So see, in options we have this ODE set, abstall, and reltol. Basically, these control the step size of the integration. That is, the smaller the step is, the smaller is the error. So basically, by controlling these abstall and reltol, we control the error. And I have used the same value for this. I want this absolute error to be 10 raised power minus 10. And similarly, here I want the same value. Okay, you can use here minus 13, but I think minus 12 is good or minus 10 is good. You can decrease this and see how your solution will deviate from the true solution. You can check it. Okay. So
Okay, sir.
now this ODE 45, what it will give? It will integrate this Z. It will integrate this RHS, that is
Are
Z double Z dot, and it will give
yes.
you Z using these initial conditions. So the solution will contain the Z. Now we want this Z. Um, we want this Z at some particular time instance only. That is why we define another time vector, that is linspace 0 t end. That is, we discretize our time 0 to t end, that is 0 to 5 seconds. We discretize it into 10,000 time steps, and at each instant of time we will find what the value of Z is. So basically we have entire solution here, but we want to pick up the Z solution only at these instant of times. Okay. How we will do? We will use deval. What deval will do? It will pull out the Z solutions at t time. So what is t time? T time is basically a set of time, 1,000 times, and it will pull out what was the Z value. Okay, so let me quickly go to white table. Maybe it will helpful. It will be helpful. So basically, we have this. Okay. So we have solution. So basically solution will be like this. There will be some X value, there will be some Y value, and there will be some X dot value, there will be some Y dot value. See, this will be a time equal to, this will be a time equal to 0. This will be a time equal to 1 step, 2 step, 3 step, 4. I'm not saying this is 1 second, 2 seconds. This is, for example, this may be 0.001, 0.002, so on. I'm just saying that this is at t equal to first time step, t equal to second time step. See, this is at time step 0. This will be the z vector. This is at time step 1. This will be the z vector. So at each instant of time, we have 4 components of solution. Okay, so but we have divided our time into 1,000 steps, and we get only our solution at those instants. Now out of this z vector, now this, what is this z vector? Now this z vector is nothing. So this z vector is nothing but this is the solution x, y, x dot, and z dot.
Y dot.
Sorry, y dot. At 0 time, at maybe 0.1 time, at 0.2 time. So we have taken 1,000 time steps. Okay. So at each time we calculate x, y, z, x, y, and x dot, y dot similarly. Okay. So there will be a row So what will be the dimensions of this Z? It will be 4 cross 1000, the dimension of this Z. And if you want only X, where is X? It is first row. So X will be equal to Z
1
of
comma 0.
1 comma colon.
Yes, 1 comma
This
colon,
is
sorry.
this is how we extract the first row. Similarly, y will be equal to Z of 2 comma colon. Similarly, x dot will be equal to Z of 3 comma colon, so on. Okay. So, okay, let us go to this. So now we have this x and we have this y. And see, this x is actually uh, it is actually 1000 values, sorry, 10,000 values. At each instant of time, it is giving you the x value. And similarly, this is giving you the y value for 10,000 time steps. So this x1 is not just a single value, it is actually a row vector with dimensions 1 cross 10,000, and this also is a row vector with dimensions 1 cross 10,000. So at each instant of time, you have this x value and you have this y value. Okay. Now how to animate? So we have got our solution. You can plot this. You can plot, write it here. So okay, let us go and plot. Uh, uh, or something. So plot x1 comma y1. Sorry, x1 comma x2. So let's plot this and stop our simulation here, and we will see what. Oh, but it will not. Okay, let's assume it will. So you can see this is how our pendulum is swinging. Okay, but you can see that it is not good, so we will use x is equal, and let us also take one more thing. X is limit, that is yes, x is I think I have it is here. Let me copy it. So now you can see it has come circular, isn't it? So basically somewhere here this pendulum is hanging. So we have to also plot the wire from this pendulum was hanging. Okay, but it is okay. We will animate it and then it will become obvious. Okay, so after this we have plotted its trajectory. Now we will animate this. By animation, I mean how mass is moving. So we have this animation, and I have written this animation separately. So there is a separate script for this. But see, the name of this animation and the name of this file, that this script is same, animation 24. Okay. Now see, we start our clock that is in inbuilt clock in the MATLAB. I take it, that is, I push the button on and it start counting the time. Then I initialize a variable t underscore equal to 0. This t underscore will store my time. That is, whenever I need what is the time, this will store. And I am initializing it as 0. So initially it has not, it has 0 value. After this, I want to plot the hinge point. Okay, so this is the hinge point. Plot 0, 0. You know, our hinge point was at origin. So let's go back to the figure and see. Our hinge point was at 0, 0. So I am plotting hinge point as 0, 0, plot 0, 0, and I use plus sign for that hinge point. This is marker plus. Okay, it will plot hinge as the plus, and I am using color 100. And I think 100 is let us see what it is. I think blue or something. I don't remember exactly what is this. We can change this. This is not a big issue. We can use 111. We can use 001 or 010. You will get different colors when you use different combinations. Okay, this will plot the hinge point. Now we want to plot our mass. For that, what we do, we plot our mass. So where is our mass initially? It is at x10 and x20. This is the initial position of the mass. So we plot the initial position, and we plot it as a red dot. This mass we plot as red dot. So this dot refers the dot, and this R refers the color of that dot. And marker size. So we set the marker size of this dot as 50. I will show you by changing this size, we can adjust to the size of this dot. So this, by this we plot a dot at the position where our mass was initially. Okay, and then we need to plot the rod also, because there is a rod which is connecting the mass to the origin. So we need to connect, we need to plot that also. So how I am plotting the, so these are names. You can name anything. I have named it as plot M1 to remember that I am plotting M1. This is what is important. This is inbuilt function plot there also. Okay, so now I want to plot the rod. So I am using plot. Okay, so initially, see where the rod is. Initially, the rod's one point is at 0, 0. It is x is 0. See, a rod has two ends. Let me draw it here. So our rod has two ends. Rod has two ends. One end is at 0, 0, and another end initially it is at x10, x20. This is the initial position of the ends of rod. So if I want to plot it, so I have to plot what I have to plot. Initial x position. Oh, sorry. What is the x coordinate of first end? That is 0. What is the x coordinate of another end? That is x10. Okay, comma. What is the y end, y coordinate of first end? That is 0. What is the y coordinate of second? X20. Okay. So this will plot a line. This will plot basically a line between 0, 0 and x10, x20. These points. Okay. These will plot a line between these 0, 0 and x10 and x20. This will plot a line. But see, this line will be plotted only between these 2 points. When mass will fall, these x10 and x20 will
X2
not
will
remain
change,
as
sir.
this. Okay, but we will see
So
how
they
we
will
will.
change.
Yeah, they will change. So 0x1, 0x2. So this will plot a line between these 2 points, and we want this line to be black. So uh, we use this K. K is symbol for black, B is symbol for blue, Y is symbol for yellow, R is symbol for red. There you can check these in Google or in help. There is also a command help. You can use. You can find it there. And then this x is equal and x is minimum. This x is equal. Why is it? Because it scales your x-axis and y-axis equally. Otherwise, what happens if MATLAB finds that there is a lot of large value in x-axis and smaller values in y, it will shrink your x-axis and it will elongate your y-axis in order to make the plot. And then what the physical intuition is lost. For example, if the trajectory was circular, it will not come as circular because x-axis has got shrunk. So in order to avoid that thing, we use this x-axis equal command. And what is this x mean, y mean? I will show this, but at this point, let it be there. Okay. So what have we done till now? We have started our watch. We are storing the time which this clock reads. We are storing in this t underscore, and then we are plotting our hinge point. We are plotting mass 1. We are plotting the rod. Okay, but see, we know that this mass will not remain at this position. It will change with time. As the time lapses, this position will change. So we need to update these coordinates, that is x10 and x2. How we will do? It goes like this. So we use a while loop. Okay, what while loop does is that we don't need to do the task each time. It will repeat this task unless and until some condition is met. So this loop will keep on going unless this condition is failed. Okay, when this fails, it will stop running. So what is the condition? Condition is speed and to torque. What is the time and what is the speed of the animation? If this is less than Tn, our animation will stop because we want our animation to run only at till this time. And since animation speed is speeding up our animation, so we need to multiply this torque by speed in order that we got the right t end. Okay, you give a thought to this thing. I hope you will get this.
Sir, what is sir, this TOC, sir?
Okay, oh, I missed. Okay, so there is a tick.
So
Tick
tick
means
or
that,
TOC.
yeah, so basically एक minute. No, so basically we have a clock. This is the clock. Let's assume this is a clock. Okay, and we have set this. When we set, so tick and talk. So this is basically 1 second. Okay, tick tock. So basically when there is a when MATLAB encounters tick, that is clock has started. When it encounters talk, it reads the time. Okay, so for example, tick, the stopwatch start. Talk, it calculates how much time has elapsed from tick. Okay, see, the code is running, it takes some time, and similarly this talk value, it keep on increasing. Okay, so basically this talk reads the time. Okay, now z equal to Duval solution t. So we have that z value, We have this z value,
Yes,
and
sir.
we
Yes, sir.
want,
And why?
sorry. We have this solution value, not
Solution,
z
solution, sir.
value. We have solution value,
Solution.
and the solution value contains all the z values at any
This
instant of time.
sir. T
But we
span.
want, this z value at a particular instant of time, not for some period of time. We want this at a
This T.
particular instant of time. So what is the time instant here? 0. See, t underscore has value 0. So we first want what is the value of z vector at time 0. Okay. So it will, this dual solution will return us the z vector at time equal to 0. Is this okay? Any confusion?
No, sir. No, sir.
Okay, so this will return us the z vector
Z1.
at
Z of
time
one. Z of.
instant t underscore, but t underscore is 0, so it will return us the initial value of z vector. Okay, and that z vector will be 1 cross 4, so it will have only, sorry, 4 cross 1, it will have 4 rows and uh, 1 column. Okay, this z vector. So basically, ideally what is our z vector? It will be this. Now you want to find at that instant of time what is the value of x coordinate, and that x coordinate is nothing but the first element of z. X2 is nothing but the second element of z. Okay, is this clear?
Yes, sir. Yes, sir. Yes, sir.
And there will be a single value for this x1. There will be a single value for this x2. This will
Sir,
not be a vector.
V1 and V2. What about V1, V2?
I don't require. If I require, I can define that, but I don't require. You can see we need only x coordinate and we need only y coordinate. But if you need instantaneous velocity and instantaneous other things, you can define. But I don't require here. That is why I have not defined. Okay.
Okay, sir.
Okay. So what we want that we need to plot instantaneous x and y coordinate. See, I have named this plot as plot M1. That is plot M1. And now what I am doing, I am trying to update this x coordinate. So I am writing plot M1 dot x data. That is, it will, this is known as handle for this plot, and it will update its x coordinate. So I am using plot M1 dot x data equal to M1. That is, update this x coordinate and equalize it to the x1 value. Similarly, plot m1 dot y data equal to x. Is it clear?
Yes, sir.
So now this and this gets updated. Similarly, plot a rod here we want this and this to be updated. So what we do, plot rod dot x data. Its x data is this.
Sir, sir, is this X data inbuilt function, or we are creating this?
No, this thing.
Yeah, yeah, yes, yes. Dot plot.
This is inbuilt. This is inbuilt. That is why. Otherwise, I could have just wrote down plot this. It would have plotted. But why I named it like this? It is that I have created a handle. Now I can play with this plot. Okay, so I can change
Change.
something. Yeah, this is
Yes, sir.
known as the handle for it. So now what I can do? I can use this handle to change its x data. Okay. Similarly, I have created handle for this plot also to change its x and y data. So what was x? 0. So origin we want the one of the ends is constant. We don't need to change this one. Only thing is we need to change this. So this should be x1, and what this should be? This should be x. Is it okay?
Yes, sir.
Okay, then we use this draw now. This draw now means it immediately draws the figure. Okay, and then see what was our initial value for this t underscore, it was 0, but we want this t to continuously update its value, because we want at each instant of time we want this z, we want this x. So this t should get updated. So what is this t equal to? It is equal to torque. That is, the watch has started. Now we this MATLAB encounters torque, so it will find us what is the value on the clock, and we are multiplying it with the speed because we are speeding it. If we don't use the speed, then t underscore is just equal to torque. Okay, so it is not that this t underscore is constant and is equal to 0. No, it keeps on storing the value what is in the clock, and again this loop will run because torque into speed is less than t, and so now this t underscore has new value. Now now this deval will pull out the solution at that t value, and that will be our z. We will extract x1 and x2, we will again update, and so at every time we are updating this x1 and x2 for these two plots. Okay, is it clear?
Okay, yeah, yes, sir.
Okay, now let us run this. So basically, when I am running this main file, this is main file. So it, when it runs and it encounters this animation 24. So it goes to this file animation 24, which is here, and runs this script. Okay, and when it run this script, it will plot these things. Okay, so now let us go to this and run. I think what is wrong? Okay, figure one. Okay, let us make this as silent and again run. Okay, I have used small amount of time. Let me increase this time to 20, and see speed is 1. Okay, just a normal speed. So this is the origin or the hinge, and this is plus, and this is the rod. Okay, let us change thing and will happen. So now let's use this um, use this as 30. No, not 30, but 80. Let's use this as 80, and also let's increase this line width. Line width. I think I'm not writing width. Let us see what will happen. I think I am not writing it correct. Yeah, some. Okay, let us delete this and see. Okay, you can now see the size of this The size of this mass has increased. Okay.
Yes, sir.
Yeah. Okay. And also see that we are dropping it from this position. Okay. Because you are using 30 degree, and that 30 degree means you are dropping it from here. Okay. Are you getting? Let us change that
Sorry,
and
theta is this theta angle with respect to horizontal or vertical?
so you should answer what it is.
Uh,
Go back
yes,
to
sir.
this.
From animation, I see it is angle with horizontal.
See, if I am writing x1 as L, okay, now let's see, x1 is this. I am writing x1 and x2 as this. How I am able to write it? It is only if,
Yes, sir. Yes, sir. Now I got it is the angle with respect to the
see,
horizontal.
x naught equal to L cos of theta is only possible if I write it like this. But your question is valid. In most of the cases,
It is vertical.
it is like this. It is like this. This is pendulum and this is vertical line and this is
Yes.
our mass m and this is theta. And this is your home exercise to do this thing. That is, use theta as this and see how your code, how you will change your code to adjust these things. Okay. For my code, I have defined the angle like this, but you can also define the angle like this and do. Uh, I don't think this is that much difficult. Okay. So let us change now the initial condition. Let us change it to uh, maybe 0. So what do you think? What will happen?
Sir, it will start from the uh, horizontal line.
Yeah. See, it is starting from the horizontal line and it drops and then see. Okay. Okay. So since there is no damping, so it oscillates with the full swing. Okay.
No, sir. It was the angle was decreasing, sir. Can you run again, sir?
Should I run again? Okay. Let's run
The
again.
angle was decreasing. I,
Okay. Let's run again. Is angle decreasing?
no, sir. Actually, it was illegal
But
to.
yeah, I will encourage you to use the damping also. And
Then it will decrease.
or maybe you can do one thing. Okay, let's use whiteboard and I will tell you how you can improve this problem. Because those are the practical ways. Okay. You can do one thing. Uh, just a minute. So this was our x-axis. This this is our y-axis, and this is our mass. And there was mg in this direction, and there was some tension in this direction, and this is, let us assume that at this instant of point this is moving with some velocity v. Obviously it will be moving, so let's assume this is moving with, and let's assume that this is moving in a this is moving in air, so there will be drag force in this direction, F drag, and let's assume that drag is equal to uh, c, some c times a modulus of v. Let's assume this. So see, you have you have now how many forces? Three forces. Again, you will write linear momentum balance, and you will get that A times that g double dot equal to something, you will again get that equation and you can solve it. Okay. I don't think there is, because you are not doing this here. Only thing you have to generate equations, rest of things are done by the MATLAB. Okay. This is the beauty of the numerical method. Otherwise, if you try to solve these analytically, even simpler problems, it will take time. Is it clear?
Yes, sir.
I think the whole code is clear now, huh?
Yeah, yes. Good.
Or is there any question you want to ask before I proceed to something else?
So I will revise this, and if
Okay.
any doubt,
Okay, you revise it, and if you have any doubt, you can come back and ask. But before closing, I want some another problem to discuss, because that is similar to this one, and uh, this will be like assignment to you to generate and to simulate it. Okay, this is from the same problem, that is the constraint a problem. So what we have, actually we have a path, or you can say we have a string, and the string is y equal to cx square. This is the equation for that string, and a bead goes slides down this track or this string. There is no friction. So this is a constraint problem, because if this string was not there, this constraint was not there, this bead would have fallen down directly, because there is gravity in this direction. So we need to write down the equations for this bead, and find out and from those equations we should get x of t and y of t. Only then we can simulate the problem. So this is the problem. Is the problem clear?
yes, sir. Yes, sir. Yes.
Okay, so this is a very nice problem, because you can visualize this problem in various ways. Like, let us think that this is y equal to x, y is equal to x square, or y is equal to cxi. Okay, you can, why what I have written down there. Okay,
See,
x square. Okay. So this is x square. So y equal to cx square. So let's assume this is the string, and the bead goes down this. This is one way of looking it. But the other way of looking it is that you have a tube. You have a tube.
It's a in tube that we
Yeah, we
yes,
have a small ball which slides down. This is
like
another way of looking it. Okay. Or another way of that,
we
you
have
have
a
some
ring.
water.
Sorry,
Yeah, yeah. You
there
were.
ring, sir.
Yeah,
Ring
ring.
or yes, sir.
Yeah, anything you can. I mean, it is a very good problem, and you can solve various things out of this. So let's discuss this problem. So this is constant. What is constant? Y is equal to cx square. So your bead, no matter where it is, it has to satisfy this thing. Its x coordinate and y coordinate need to satisfy this equation. This is what we mean by the constant. When you put this string here, this string tells this bead, go and satisfy this thing. I have no objection if you move here and there, but unless and until you satisfy this, I am happy with you. Otherwise, I will break you. This is what we mean by the constant. Is it okay?
Yes, sir. Yes.
How can this bead go out? Only by breaking. Okay. So we need to find the equations of motion. As usual, we will use linear momentum balance equation. What linear momentum balance equation is, that we sum the external forces and equate those to the rate of change of linear momentum. So let us first draw the FBD, free body diagram for this bead. So this is the path which I have showed in dashed line, this, and this is the bead, this is the gravitational pull, mg, and obviously there will be a constant force due to this surface. And since I have assumed that there is no friction, so there will be no force in the tangential direction. So there will be only one force, which will be contact force, and that will be normal to the contact, normal to this trajectory. And
So
that
what
force
is
I
this
have,
lambda there? Lambda
yeah,
cap?
I'm going to
Okay.
explain this. So there will be a normal force, and I have represented that normal force as F, which is the magnitude of that normal force, and n cap is the unit vector in this direction, the unit vector normal to the path at this position, and this lambda is the tangential unit vector parallel to this path at this point. Okay, so this is the normal force, and minus mg j is the gravitational force, and I am equating it with mass times acceleration. This is from this. Okay. Now I have also told you that n is unit vector normal to path and lambda is tangent to the path. Okay, so this unit vector n, we can write this unit vector as nxi nyj. Okay, let me go to the whiteboard. So basically we have this whatever. So we have this path. Okay. So at any instant we have this normal vector n, and we have this tangential vector lambda. Unit vector. These are both unit vector. Now see this vector. This is normal. I can drag this vector and put it here. Okay. Now this unit vector has two components. One is nx, that is along x-axis, and one is along y-axis. So I am calling this nx and ny as x and y component of this unit vector. So I can write this unit vector n as nxi plus nyj. Okay, so these
Yes.
are okay. So these are the two components of the unit vector, normal unit vector. Okay, and substituting this n here, I can write this fn minus as f times this n like this minus mg equal to ma. Then collecting the I and j terms separately, fnxi plus fn minus mgj equal to m times x double. Acceleration is nothing but x double dot I plus y double dot j. So I get this equation. Now this is a vector equation, so we can break down this equation into two scalar equations. So taking dot product of this equation with I, we get fnx equal to mx double dot. Because this is j, this will be the dot product with I will be 0, and here also the dot product of this term with I will be 0. So we will be left over with fnx equal to mx double dot. Okay. Similarly, taking the dot product with j, we will get this equation. Now see, we have F is unknown. We don't know what the contact force is, because that is a constant force, and we don't have any law for constant forces. Okay, so we have x double dot and y double dot as unknown. So we have three unknowns, but we have only two. We have only two equations. So what to do? So what is your opinion? What should we do? We have to get x double
Sir,
dot and y double. Yeah.
sir, three variables and two equations. Yes, sir.
Yeah, there are three variables. See, f we don't know, x double dot we don't know, y double dot we don't know. M we know, nx we know, ny we know, because we have that path, we know these things. But x double dot, y double dot, and f we don't know.
Yes,
So
sir.
how we can get this? How can we solve this problem? We have three unknowns, but we have two equations. We need one more equation to solve it, isn't it?
Yes, sir.
So that is why we take the help of constant equation.
Equation, sir. Equation.
Yeah, constant equation. What was the constant equation? Y equal to cx square.
Yes.
We differentiate it to get the constant in terms of velocity. So this is the constant in terms of velocity. Constant in terms of acceleration is this. So this is the first, this is the second, and this is the third equation. Okay. Are you getting?
Yeah, yes, yes, sir. Yes, sir.
Okay, we can rewrite these 1, 2, and 3 as mx double dot minus 0y
Then make a
minus nx equal to 0, 0, and that equal to this. So writing in matrix form is this, this, and this. And what you want x double dot, y double dot, and f. So
yes.
if this is A and this is B, then we can find this using MATLAB previously how we did. Okay, so uh, so everything is clear. Okay, so you got x double dot and y double dot. You give it to ODE. ODE will integrate, and you plot and you simulate your things. Okay. So, but the
Then
thing
it is
is,
same. Yes.
yeah, from here it is same. Nothing is different. So now the only thing is that what is this nx and ny? I have told you that
That
these are
these
the
are
x and
component
y
of this
of
component
unit
of
vector. Yeah,
this
let us see how we can calculate this thing. Okay, let me go to the whiteboard. Okay, so basically this was your normal and this was your tangential, and this is the equation y equal to cx square. Okay, so I have my own way of calculating lambda and this normal. You can also do it in various ways, but I think this is the most efficient way because I think it like that.
sir.
Okay,
Sir, uh, uh,
yeah.
sir, we can calculate lambda and n cap by doing this. I remind one method. By taking a tangent, an equation of tangent will be the lambda dash, and the equation normal to the by taking the minus of m divided by
Mhm.
dx, we'll get the equation of n.
Exactly.
Yes, sir. Yes.
Exactly. I have done the same. So I think our thinking match. That is
Yes.
good. Okay, so what we will do, we will use the concept of def we will use the concept of tangents. How we will use. Okay. Okay. So let us take this point. So if we go in this direction by 1 unit, how much y will change?
That
If
is
we go
called as a
in,
gradient. That is called a gradient of
that,
the line.
that is known as dy by dx,
More
isn't
precise.
it?
Yes, sir. Yeah. Okay.
So if we go along x-axis by 1 along y-axis dy by dx be the change. So this changed by 1, and this is nothing but our lambda
This will
cap. This
yes.
is our lambda cap. Okay. So, but this is the unit vector in, but we don't know if this is a unit vector or not. We don't know. This cannot be a unit vector. Okay. So let us in general call it as lambda vector. This may see this is 1 and this is dy by dx and this is 1, and we are joining this. Obviously this will not be a unit vector, isn't it? Because its magnitude should be 1, but it is greater than 1. This is 1 plus
Yeah.
something, this will be greater than. But one thing is
Yes. Yes.
clear, that it is tangent to the path, so it is in the same direction as lambda hat. That is why I called it as lambda vector. So what is
Okay.
lambda
Yes.
vector? Lambda vector is nothing but 1 along I plus dy by
So
dx along j.
J.
Okay. So we know if we want to calculate a unit vector in any direction, it is nothing but lambda vector divided by mod of vector, isn't it? And that is equal to, what is lambda? That is I plus dy by dx j upon mod of lambda. Mod of lambda is nothing but under root of 1 plus dy by dx whole square. So this is our lambda, lambda cap. Okay, is it okay? But we
Okay.
need to
Yes.
find, okay, let me do this. What is happening? Oh, okay. So what we need n hat. Okay. So n hat we need, and n hat is nothing. We are saying that is nxi plus nyj. So basically n hat has two components, x component and y component. But one thing is for sure, that n is perpendicular to lambda. So if we take the dot product, it should be 0. And what is n? It is nxi plus nyj. And what is lambda? This is this. So let me make it short and write it like this. I plus dy by dx, I will call it as y dash j upon under root of 1 plus y dash square. Okay. So when I take the dot product of this n and lambda hat, what I will get? I will get x component of this multiplied by x component of this, and that is nothing but n x upon under root of 1 plus y dash square plus y component of this and y component of this, that is n y dash upon under root of 1 plus y dash square, and this should be equal to 0. This and this gone, and we are left over with nx equal to minus times ny dash, and so we have a freedom. We can choose anything for this nx, and let me choose. Okay, I think making one mistake. Yeah, here I am making a mistake. I should divide this by nx,
So
uh, and
mod of n there.
yeah, that is nx square plus ny square.
Root.
Okay, yeah, this I should do, and then that will come out and become 0. That is secondary thing, but I should write as nx square plus ny square. Similarly, nx square plus ny square. Okay, this will again come to 0, but this was important. So I can take anything for this nx. let me take nx as 1. Okay, I am
Yeah, yeah.
taking nx as 1, uh, and nx, if I am taking as 1, what will be the value for nx equal to 1? What will be the value for ny? It will be minus 1 divided by y dash.
Y dash.
And what is y dash? Y is equal to cx square, y dash equal to twice cxx.
Dy by dx.
Uh, sorry,
Increase it.
this.
Yeah. Yeah.
I have forgot to switch on my adapter.
Right.
Okay,
Tobo.
okay. So this is minus 1 upon twice cx. So this is nx and this is, but I think I should correct my statement what I had made previously. Let me go back. Okay, so if this is a unit vector, then nx and ny. This is not nx and y. I should call this as something else. This is nx
Yeah,
dash
yeah,
and
yes.
ny dash. Okay,
Yeah, yeah.
this is nx dash and ny dash. Okay, then what is nx dash and ny dash? So basically our, I will write here, uh, actually our n is, uh, okay, I will change it here, not there. Let me change it here. Uh, Let me change it here. So I will call this as nx dash and ny dash 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 and dash everything, so that everything else remains uh, good. Okay, so now previously we know that our n was nothing but it was equal to nxi plus nyj was, this was equal to this thing. Okay, what is now x component? X component is nothing but
And
nx dash upon under root of nx dash square plus ny dash square I plus ny dash upon same thing j is equal. What is nx dash? Nx dash is 1. What is okay? So under root of 1 plus, what is this ny dash? This is mm, minus 1 divided by 2cx square. Okay, so this is I plus, what is this y dash? Ny dash, it is same, minus
1
1
upon
divided.
2cx.
Okay, so now see, you have got both things. You have got nx, which is this 1 upon this, and you have got ny, which is 1 upon this. Okay, now you have everything. So coming back to our equation, this equation, so you have nx, you have ny, you have m, you have everything. You can find this matrix, isn't it?
Yes, I see.
Okay, so any question before we close today's class? Any question?
सर अभी तक तो कुछ नहीं है, बट सर पहले रिवाइज करेंगे फिर बाद में देखते हैं।
Okay.